Hello everyone, how are you doing? I trust you are all doing great. James from JTS Smith Tutoring here. We are continuing with our algebraic properties of matrices. We are still looking at inverses. Right. Proof if B is invertible, then A B inverse is equal to B inverse A if and only if AB is equals to BA. Wonderful. So this is what we need to prove, right? So we are given here the condition that if and only if, which is this is a biconditional statement. So we need to consider the forward direction or implication of this statement as well as the backward direction or implication. All right. So we'll start with the first one. So we are saying if this is true, then this is the case, right? Okay, let's get going. So if AB inverse is equals to B inverse A, then AB is equals to BA. All right. So we are assuming that this is the case. So what we are going to do is you multiply on the right throughout by B, and this is going to give us this, right? So we know that when you multiply a matrix with its inverse is going to give you an identity matrix. And when you multiply an identity matrix with a given matrix, you're going to get that very same matrix. This is exactly what has happened here. And boom, here you are. You've got your A here. All right. Cool. Awesome stuff. Now, what we are going to do, we are now going to multiply on the left throughout by B. And this is what we are going to get right here. All right. Oh my God, I love this. So you said, if this is true, then this is going to be the case. All right. So BA is equal to AB is exactly what we have right here, because this given condition here, it has actually forced A and B to commute. So this statement is exactly just like saying AB is equal to B. So we have actually proved that forward direction. Now let's look at the backward direction. The backward direction now says, if this is the case, then this, right? So if AB is equal to BA, then AB inverse is equal to B inverse A. So we assume that this is the case. So you're going to multiply throughout on the right by B inverse. And this is what we are going to get. Right. Our next step after that is to multiply on the left throughout by the inverse of B. Boom. So just like what we had here, it forces these two to what? To commute. So this is just the same as AB inverse is equal to B inverse A. Thus, we conclude that since both directions hold, if B is invertible, then AB inverse is equals to B inverse A. If and only if AB is equals to BA. Did you see that, Jimmy? You threw that miles away. Oh my God, I love this. Allow me to go now. Mama taught me a good visitor knows when to leave, or she would say a good dancer knows when to leave the dance floor. Till we meet again, don't do what Mama and I wouldn't do. See you soon.